Hello, this is Mr. Stansbury. I'm going to take you through the 6H notes on problem solving. Okay, so at the end of this, you should be able to turn real-life type problems into linear equations and be able to solve them. Alright, so let's take a look at some examples. First one is example 25 from page 188. And this says two numbers have a sum of 45 and a difference of 13. Find the numbers. Okay, so I'm just going to say let x equal the first number, and then y is going to be the second number. Okay, because we don't know what either one is, so we know that the two numbers have a sum of 45. So I know that if I add these two numbers together, x plus y should give us 45, right? And then I also know if I subtract the two, then it should give me a difference of 13. So I could do x minus y should give me 13. Okay, so this is going to be, for most people, the most challenging part is just to try to turn this word sentence here into a mathematical sentence or two. Okay, so once you get this, now it's just like what we did in the previous section, which was solve the linear equations, right? Nice part about this is the y's are opposite. So if we add these together, we get x plus x is 2x. The y's cancel out, and we get 2x equals, what, 58? So we divide both sides by 2, and we get that x equals, let's see, that would be, what, 29? Okay, so one of them is 29. Let's figure out what the, excuse me, what the other number is going to be. So we can plug x equals 29 into either one of these. I'm going to plug it into the first one. Excuse me. I'm going to plug it in this first one here because y is positive. So I'm going to bring this over here and bring this x equals 29 in here. So 29 plus y should equal 45. So subtract 29 from both sides, and we get that y equals, what's that going to be, 16? Yep. So y should equal 16 and x equals 29. So our two numbers are 16 and 29, right? Let's just double check to make sure that this is correct. Right? So again, as long as we wrote correct formulas up here in the first place, then we should be okay, right? So 16, well, actually I guess if we're going to be official here, we said that x was 29, so if we do 29 plus 16 should give us 45, and if you add 29 and 16 you indeed get 45. And then let's do 29 minus 16 should give us 13. If you take 29 and subtract 13, you get 13. So both of those work, so then we know that our two numbers have to be 16 and 29. Alright, let's take a look at another example. Okay. Excuse me. This one is example 26 from page 188, or at least something that's close to that. Alright, so 5 Darth Vader china plates, as displayed over here to the right, and 14 Mike from Monsters Inc. mugs, this one here, cost $1.30 altogether. Wow, that's quite a bargain. You have to agree. Who would not want to have a full place setting of Darth Vader china plates and Mike, let's see, Mike from Monsters Inc. mugs? Come on, that's fantastic. 8 plates and 9 mugs cost $1.41. Find the cost of each Darth Vader china plate and each Mike mug. Okay, so just like what we did on the one before that, this problem before, we want to turn this here into some mathematical equations. So let's let D equal the cost of each Darth Vader plate, and then let's let M equal the cost of each Mike mug. Alright, so we know that if we buy 5 Darth Vader plates and we buy 14 Mike mugs, that it's going to cost us $1.30, right? We also know that if we buy 8 Darth Vader plates and 9 Mike mugs, that's going to cost us $1.41. Alright, so now we've turned this here into 2 mathematical equations. So it's basically a system of equations. Alright, so now we want to solve this one here. So you could solve either one of these equations for either D or M and then substitute in, but again, I still prefer to do the linear equations, the elimination method, so I'm going to try that. So let's see, we've got 14 and 9 and we have 5 and 8. 5 and 8 to me are going to be easier to work with, and it should be easier to work with for pretty much all of us. So what I'm going to do is I'm going to multiply. I can't just multiply 5 by something nice to get -8, and I can't multiply 8 by something nice to get to -5 to get these opposites. So I'm going to multiply both top and bottom. And again, the easy way to do that is to just take this number here, multiply that by 5, take this number here, multiply this by 8. Now both of these would be 40D, but one of these needs to be -40D, so one of these two out here need to be negative. So I'm going to just turn this one here into a negative, and then let's distribute the 8 through to all 3 pieces, and this -5 to all 3 pieces as well. Okay, so when we do that, 8 times 5D gives us 40D. 8 times 14. 8 times, oops, gotta turn it on. 8 times 14 gives us 112 plus 112M equals, and then let's do 8 times $1.30. 8 times 1.3 gives us 10.4. So we've got 10.4. Alright, and then down here, -5 times 8D is -40D. And again, that's the key. We got 40D and -40D, so those will cancel out. -5 times 9M gives us -45M. And then -5 times 141. Let's try that. -5 times 1.41 gives us -705. Okay. Now we can add these together. Add these two lines together, and then these D's are going to cancel out. So we have -112 minus 45 gives us 67M equals, and then we got 10.4, $10.40 minus $7.05, and we get $3.35. Alright, so 67 Mike mugs would cost $3.35. Wow, what a bargain. Divide both sides by 67, and we get the number of Mike mugs. So 335 divided by 67 gives us 5 cents a mug. Wow. Come on, that's a great deal. 5 cents per Mike mug, for each Mike mug. Alright, so now that we know what the Mike mugs cost, let's go back and calculate what the Darth Vader plates are going to cost. So again, you can plug it back into, I'd suggest plugging it back into one of these two original equations. I'm going to use this first one here. So, let's bring this equation down here. 5 times D plus 14 times m, which we now know is 0.05, equals 1.30. Right? So 5d plus 14 times 0.05 is 0.7. So we get plus 0.7 equals $1.30. Alright, so we subtract our 0.7 from both sides. And we get 5D, 5 Darth Vader, I keep saying Darth Vader, it's probably because I watch Cars too often with my son, but 5 Darth Vader China plates is going to cost us 60 cents. Divide both sides by 5, and we get that the Darth Vader plates, a little bit more expensive than the mugs, are 12 cents each. Okay? So, again, we can plug this back in really quick just to double check that we've got them right. And again, this is such a bonus to be able to check it like this, because then you can pretty much guarantee yourself of getting 100% as long as you've got an idea of what's going on, because you can check your own work and see if you've got it right. So let's do that. 8, oh, we don't need that. Let's use this first formula here. So 5 times d, which is from over here, 0.12, plus 14 times m, which is 0.05, should equal $1.30. So let's calculate that out really quick and see what we get. 5 times 0.12 plus 14 times 0.05, and look at that, we get 1.3 equals 1.3. So that one's good. And then let's double check the second one, and that is 8. It's this one right here, 8 times d, so 8 times 0.012, oops, 8.012. Sorry, it's 0.12. There, I finally got it right. Plus 9 times 0.05 should equal 1.41. Alright? So 8 times 0.12 plus 9 times 0.05 gives us 1.41. So that works. So then we know how much each one's cost. So each Darth Vader plate is 12 cents, and each Mike mug is 5 cents. Again, what a bargain. Alright, so that's that one. Let's take a look at one last example, and then we will be done. Alright, in Alanis Morissette's pocket, she has only nickels and dimes. How many of each does she have? If she has 24 coins altogether, and their total value is $1.55. Okay, so let's let n equal number of nickels. Okay, and then let's let d equal number of dimes. Alright, so let's see, it says how many of each does she have if she has 24 coins altogether, so that we know that the number of nickels plus the number of dimes is going to equal 24. Okay, and we also know that their total value of both of all the coins that she has in her pocket is $1.55. So nickels are worth 5 cents each, so 5 times the number of nickels plus 10 times the number of dimes should equal, and since we're doing this as cents, we'd want to convert this into cents, so that would be 155 cents. Right? So here's our two equations. right? Now again, this one might be, someone might elect to do substitution on this instead of linear combinations or elimination. I still like doing elimination just because I think it makes it easier, so I'm going to do that. But you could solve this for either n or d and then plug it in and away you go, so whichever one you want to do. It's going to be easier to put this, we have n and 5n, so if I multiply this top line here by -5, I'm going to get my -5n plus 5n, which will help me eliminate. So let's do that. -5n, -5 times d is -5d equals 24 times 5 is -120, right? And then I'm just going to bring this one straight over. 5n plus 10d equals 155. When I add those together, that goes away and we get 5d equals, let's see, 55 minus 120 is 35, right? So divide both of these by 5 and we get that the dimes should be 7, right? And then what we want to do is figure out then how many nickels we're going to have, right? So from that, let's take this equation. I think is going to be easier to work with. It'll work with either one, but nickels plus the number of dimes, which we now know is 7, equals 24. So subtract 7 from both sides, and we get that the nickels have got to be 17. So she's got 17 nickels and 7 dimes. Again, let's double check to make sure that it works. And we've got the nickels, which is 17, plus the number of dimes, which is 7, should equal 24. If you take 17 plus 7, you get 24. So that works. And then with the second one, 5 times 17 plus 10 times 7 should equal 155. So 5 times 17 is 85 plus 70. And if you add 85 and 70, you get 155. And that also works. So Alanis has 17 nickels and 7 dimes in her pocket. Alright, and that's all there is for this section. So now you should be able to turn real life type problems into linear equations and be able to solve them. Alright, feel free to ask if you have any questions. Thanks.